Now we will be diving into the concept of alternate angles or alternating angles. When we talk of angles that alternate angles, those angles lie on opposite sides of the transversal and between the parallel lines. They are equal in size, and always when you want to look at them, look out for the Z or N shape. So these are the angles that they are referring to. Here they say this angle is equal to this angle when you're looking at your Z shape, and this angle is always equal to this angle. Bear in mind that this line here, which is this one and this one, these two lines are parallel, are said to be parallel, and this one acts as a transversal. So again, this one is a transversal, and these two lines are parallel. This one and it's parallel to this one. Whenever you are looking at this, try to make sure that you observe something that is of this form. By the way, let us dive into details. Just don't underline here. Okay, so this is what we are looking for whenever we're looking at alternate angles. But in this case, I'll just take you through it. Okay, I'll just throw my diagram here. And I'll try to make sure to make diagram is as visible as it can. So in this case, we have these lines. These two lines are parallel, and our label is A, B, C, D, E, F, and here I have G, and here I'll be having H, which is the point of intersection. Okay. Now I want us to look at this. I'm labeling this one as 1. Okay, make this one 2, make this one 3, make this one 4. 1, 2, 3, and 4. Okay, so in this case, when we want to look at the alternating angles, we said in this case we are looking at a Z and N shape. In this case, are we having any N shape? No, we won't have N shape because we won't be having an N shape because we are looking at parallel lines that are made to be horizontal, and the transversal is the one that is diagonal in this case. So look at this one now. We want to look at Z. This is our Z. Okay, this is the Z that we are looking for. Okay, in this Z, you can tell that here is an angle that this angle is equal to this angle using the definition that was stated to us. So we'll be having G3, angle G3 equal to angle H1, of which is something that I think we saw previously where we're trying to relate the information that we had on vertical opposite angles as well as corresponding angles. But now we are now going straight to the point using the concept of alternating angles. So the main reason is because it's alternating. We're looking at alternating angles. Whenever you are writing this, make sure that you specify which lines are parallel, because you can't say alternating angles are equal without having a valid reason. The reason has to involve lines that are parallel. The reason is because AB, we are told that it is parallel to CD. Then you'll be completed with writing your reasoning. And then we want to look at this portion again. This is Z also, by the way, good people. Okay, this is Z. It's just that my Z is a bit stretched. What have you done now? It's a parallel line, it's a transversal, as well as what now? Another parallel line. So here is my Z shape. So my Z shape in this case is this one. So you see now, I also have G4, which is equal to what? H2. The reason is because the angles are alternate. And I will also specify that AB is parallel to CD, because we have to look at a parallel line, transversal, as well as the other parallel line. Can I come up with another Z shape here? Unfortunately, I don't think I have any Z shape from this diagram. Then now I want to look at it when I have to check for an N shape. So these two lines are parallel and they are splitted by a transversal here. So transversal is just the line that intersect these parallel lines. So, and I have a line EF which catches or which intersects the parallel lines at G as well as H. So here is the point of intersection. Okay, so now my G is now labeled as, okay, I have G1 here, I have G2 here, G3 here, G4, H1, H2, H3, and H4. Now I want to look at another shape. Now I said that when I have my parallel lines in a vertical shape, or it can be diagonal, it depends, but we are looking at a Z shape as well as what? As well as N shape. So let us look here. In this case, we'll be having an N shape. Okay, let's just follow our N. Okay, here's my N. So when you look at my N, you know which angle is that has to be what? To be alternating. So in this case, what have I done now? So this angle and this angle, these two angles are alternating angles. So I have angle G3 that is equal to angle H1, and the reason is they are alternating. So alternate angles YAP is parallel to CD. Okay, again, let's just look at another angles that we can look off that are alternating. Okay, we said this is our N, and we can have these angles. N is being stretched now. It's a parallel line, and then now have a transversal here, and again on another parallel line. So you see my N is a bit stretched, but that does not defeat the purpose of the proof. So in this case, here is my G2. G2 has to be equal to what? H4. Okay, G2 is equal to H4. G2 is equal to H4. And the reason is I'm looking at angles that are alternating. Alternate angles. I said the reason is not enough if I did not mention a line that are parallel. AB is parallel to CD. Then my reasoning will be then complete. So when we have a parallel line and transversal, in most cases we only have two angles that are alternating, but when we are looking at the corresponding angles, we have many corresponding angles. Yeah, we have as many as possible corresponding angles. Normally there are 4, but when you're looking at alternate angles, they are 2 when we are speaking of such scenario or of such a diagram. So we've covered the concept of properties of lines, corresponding angles, as well as alternating angles. So in my next video, I will then be talking about the co-interior angles.